We've studied lines. Now we're going to study lines a little further. And we've also studied angles. We're going to put what we know about angles into our study of lines. And in particular, we're going to look at angles made when you intersect two parallel lines with a transversal. Now, here I've got a drawing of two lines that intersect. And where they intersect, four angles are formed: angle 1, angle 2, angle 3, and angle 4. And what I want to do, first of all, is just point out some things that we already know about these four angles. One, we know that certain of these angles are equal in measure to others. So for example, the measure of angle 1 is equal to the measure of angle 3. And we know that because they're vertical angles. Okay. Now, that's not the only pair of vertical angles. We know that the measure of angle 2 is equal to the measure of angle 4. Yeah. So we know that. Those are the vertical angles. Now, we also see some linear pairs here. In other words, angles that add up to 180. So we have this angle and this angle. If you put those together, if you take that measure and this measure, you'll get 180 degrees. So we say we have some linear pairs here. We know that the measure of angle 1 plus the measure of angle 4 is equal to 180. We know that for sure. Now we also, that's not the only set here. We have the measure of angle 1 plus the measure of angle 2. That equals 180 as well. Okay, so these two angles, that adds up to 180, and those add up to 180. Now we also, we're not done yet, because we know that the measure of angle 2 plus the measure of angle 3 equals 180. And the measure of angle 3 plus the measure of angle 4 equals 180. In other words, we've got these two angles, these two angles, these two angles, and these two angles. All of them add up to 180. Okay, the pairs. They're all supplementary. Now I want to do this. I want to take this line right here, this one right here, and copy it. And I don't want to change the direction or anything. I just want to copy it and move it. So here, I'm copying it, I'm moving it down here, and now I've got this line. Now notice I didn't change the direction or anything. All I did was copy it and move it. So this line is parallel, and I'm going to denote that it's parallel by putting a little arrow right here. I'll put an arrow there and there. And that's what we're going to use to show that two lines are parallel. Now I'm going to name the angles down here. I'm going to name these 5, 6, 7, and 8. Just like I named those four angles above as 1, 2, 3, and 4. Now notice I have corresponding angles here. So what I mean by that is this angle 1 corresponds to angle 5 because it's the same angle. All I did was move it. So we could say here that the measure of angle 1 is equal to the measure of angle 5. And we know that the measure of angle 2 is equal to the measure of angle 6. And the measure of angle 3 is equal to the measure of angle 7. And the measure of angle 4 is equal to the measure of angle 8. Okay, now these are corresponding angles. Corresponding angles. Okay, and corresponding angles are congruent. So that's something we want to take note of, that these angles right here, corresponding angles, are congruent. And I'm going to put, I'll put a little square around that to help us. Whoops, that's not a square. Let me see here. There we go. That's a little better. Okay. So corresponding angles are congruent. Now, that's the first thing we want to take note of when exploring how we have parallel lines cut by transversal. That's the first thing that we want to take note of, is that the corresponding angles are congruent. Now, also, we have other things that we can take note of here. For one thing, that some other classifications. Notice that we have interior angles. Notice I have this interior angle, this interior angle. In other words, they're inside the parallel lines. So I have these interior angles. I have 2, 3, 5, and 8. Those are interior angles. Exterior angles are 4, 1, 7, and 6. 4, 1, 7, and 6. Okay? Now, I want to take note of some properties of these. First of all, the interior angles. Now, notice that, let's just think about this a second. I'm going to look at angle 2 and angle 8. So I want to look at the measure of angle 2 and the measure of angle 8. Okay? Now, let's think about this. These are alternate interior angles. In other words, you have on this side of the transversal, you have 2, and on this side, you have 8. They're alternate interior. Now, 3 and 8 are consecutive interior angles. So 3 and 5, alternate interior. 2 and 8, alternate interior. 3 and 8, consecutive. 2 and 5, consecutive. Now, here's the thing about angle 2 and angle 8. Angle 2 and angle 8 are going to have the same measure. Okay? So angle 2 and angle 8 have the same measure. Now, here's how you can think about that. Remember that angle 2, let's go back up here and look at this. Remember that angle 2 is equal, the measure of angle 2 is equal to the measure of angle 6. So angle 2 and angle 6 are the same. Now, also remember that angle 6 and angle 8 are congruent because they're vertical angles. So if the measure of angle 2 is equal to the measure of angle 6, and the measure of angle 6 is equal to the measure of angle 8, then the measure of angle 2 must be equal to the measure of angle 8. Okay? So what we have here is that alternate interior angles are congruent. So here we have the measure of angle 3 is equal to the measure of angle 5. Okay? So alternate interior. And I'm going to say congruent. Okay? So alternate interior angles are congruent. Now, the same is true for the alternate exterior, and you could make a similar argument. So angle 4, the measure of angle 4, is equal to the measure of angle 6. And the measure of angle 1 is equal to the measure of angle 7. And those are alternate exterior. And those are also congruent. See? So this angle, alternate exterior. This angle, alternate exterior. Okay? Now, consecutive interior. So let's look at let's go back to interior now. Consecutive interior. So let's look at the measure of angle 3 and the measure of angle 8, those are supplementary. Okay? The measure of angle 2 and the measure of angle 5, supplementary. The measure of angle 4 and the measure of angle 7, supplementary. Okay? The measure of angle 1 and the measure of angle 6, supplementary. Okay? So those are consecutive exterior and consecutive interior. So notice, consecutive interior and consecutive exterior, those are supplementary. Okay? So, angle 4 and angle 7, they add up to 180. So those are consecutive angles. Interior and exterior are supplementary. Okay? So we have congruent and supplementary. So those are the supplementary angles. Okay, so that's a lot. Now, really, if you study these things, it's pretty obvious which angles are congruent, which angles are supplementary. Those are your two choices. When you have parallel lines cut by transversal, you either have angles that are supplementary or angles that are equal. Okay? Supplementary or congruent. So let's look at this. Let's suppose we want to find all of these angles, 1, 2, 3, 4, 5, 6, 7, and 8. We want to find the measures of all of them. Now, we're told that angle 1 is 150. Okay? Well, then you immediately know that the measure of angle 4 is 150 as well, because they're vertical angles. Okay? And you know that the measure of angle 5 is 150. Okay? So let me just put these. 150, 150. Because 5 is the corresponding angle. And you know that the measure of angle 8 is 150. Okay? So we have 4 150s. Now, those are all congruent to the measure of angle 1, or angle 1. Now, everything else is going to be supplementary. So angle 2, 30 degrees. Angle 3, 30 degrees, because those are vertical angles. Then you have corresponding angles down here, 30. And there you have a vertical angle, 30. So all the other angles are 30. Okay? So you get the congruent ones, the vertical, and then everything else is supplementary. Okay? See? So 3 is supplementary to 1. 2 is supplementary to 4 and 1. But you see how this works. It looks like a lot, but it really makes sense. There's only congruence and supplementary. Okay, so let's look at this one. Notice we have two parallel lines. Here's our parallel lines, and we recognize it because of the little arrow here. And here's another parallel line, and a little arrow there. Okay, now, so we have these parallel lines cut by transversal. Now we want to figure out, and we're told that this angle right here is 35 degrees, and this angle here is 80 degrees. And we want to see if we can figure out anything else. Well, I'll write this in red, okay? So let's see what we've got. We've got this angle here, and this angle is 35 degrees. And it's 35 degrees because it's a vertical angle of that 35. Yeah. So we've got that angle immediately. Now, let's see what else we can just get right off the bat from looking at this. Now, if you look at this right here, all of these angles, this one, and this one, have to add up to 180. So this angle right here must be 180 minus 80 minus 35. That's what that's got to be, right? So 180 minus 80 is 100 minus 35. And what is that, 65? Okay, so I put 65 degrees right here. Okay, so we've got all of those angles right away up there. Now what I want to do is I want to see if I can figure out what these angles are down here. I'll call this one angle 1 and angle 2 and see if I can figure out what those are. Okay, now so notice that I have this line right here, and I have 35 degrees here and 80 here. This angle right here is going to need to complete this. This has to add up to 180. Plus, I have a vertical angle here. So I know right away that this is going to be 65 degrees. I know that's going to be 65 degrees for sure. I have a vertical angle over here that's 80. So look at all these. Okay. Okay. Now, I've figured out what all those angles are. Now, this is going to lead to something kind of a big notion that we're going to use quite a lot. But anyway, I got all of those angles there. I was reasoning through, just given 80 degrees and 35 degrees. Now, let's take a minute to dig this. I've got a parallel line, another parallel line, and here's a transversal. This 80 degrees, if I do the alternate interior, I've got that angle 1 is equal to 80 degrees also. And likewise, angle 2 is equal to 65 degrees. Now, here's what I wanted to point out about this. Notice that if you add these, 35, 80, and 65, you get 180. And dig this. This is just, there's nothing special about this. This is a triangle. So what I wanted to do is give you this, just show you something that we're going to refer to quite often. And that is the sum of angles in any triangle is going to be 180. 180 degrees. That's just the way it is. And it all can be shown from this idea that we've been exploring with parallel lines cut by a transversal. Okay, so I just wanted to bring your attention to that. The main thing is the sum of the angles of a triangle is 180, and we'll refer to that quite often. Okay, now let's look at another practice problem. Here I've got two sets of parallel lines. I've got this line is parallel to this one, and notice I've indicated that with a single arrow there. This line is parallel to this one, and notice I've got little double arrows there. That indicates which lines are parallel to which lines. Okay. Now, what we need to do is figure out what X and Y and Z are. Okay, so we don't know that right now. We do know that this right here is, whoops, I deleted it. We do know that this right here is 72 degrees. Now, just looking over here, we've got a parallel lines cut by a transversal, and these are alternate interior angles. Well, alternate interior angles are congruent. So that means that 2x is equal to 72. That means that x is equal to what, 36? Yeah. So x is equal to 36. Well, heck, that's part of what we needed to figure out. And we've got that already. Now let's see here. If x is equal to 36, let's see if we can figure out something else here. So just trying to work our way through this, maybe I can figure out what z is. Now, notice that now I know that this, if x is equal to 36, this, of course, is 72 degrees. Okay, that's 72 degrees. Now, let's just look at, let's look at this. Let's look at this parallel line and this parallel line and look upon this as a transversal. And if we do that, notice what we've got. We've got this angle and this angle. Well, those are consecutive interior angles, and they are supplementary. So we've got 4z plus 72 equals 180. So that gives us 4z is equal to, let's see here, 180 minus 72, I guess that would be 108, right? Okay. And if we divide by 4, that will give us z is equal to, what is that going to be? 72, or no, I'm sorry, 27. Yeah, 27. I don't know. Where's that? Okay, z is equal to 27. 4 times 27 is 108. Yeah, okay. So now we've got x and we've got z. Now I just need to figure out what y is. So let's see here. I have this right here, which if you do 4 times 27, you're going to get 108. So this is 108 degrees. And these are alternate interior angles. So I can figure out what this angle is. This is going to be 180 minus 108. So this is 180 minus 108. Okay, so if we take 180 minus 108, we get 72. Okay, and we could have figured that a different way, but we get 72. So this right here is 72. And notice I could have got that by just realizing that these are corresponding angles. This one and this one are corresponding angles. Now I'm set up to find out what y is because these right here are vertical angles. So I've got 5y plus 2 has got to equal 72. So that will give me 5y is equal to 70. And then if I divide 70 by 5, I get 14. So we've got x is 36, y is 14, and z is 27. There we have it. Okay, so that's the way this game is played, just like that. Now let's look at this one right here. So we've got angle 1 is equal to 107, and angle 11 is equal to 48. So I'm going to just mark in red what I immediately know. If angle 1 is 107, then angle 7 is 107. See, because those are vertical. If angle 11 is 48, then angle 13 is 48 as well. Okay, so I've got those right away. So we've got, this is 107. That's 107, and angle 11 is 48. So I'll just go ahead and write those in here. Now, there are certain angles that are supplementary, like angle 2 and 1 are supplementary. So angle 2 is going to be 180 minus 107. So this is 73 degrees. Okay, 73 degrees, and therefore angle 8 is 73 degrees. Okay, now dig, if you will, that I've got all 4 of these angles right away. Now I can get all 4 of these down here right away as well, because I can just do the supplementary thing. I can take 180 minus 48, and that's going to give me 132. So I've got 132 here, and the vertical angle 132 there, So now I've got all of those. Now, what's left for me to do is just look and see, okay, I've got parallel lines cut by a transversal. Okay, so for example, I can come up here and I can look at this transversal and these parallel lines. And I can immediately get 3, 4, 5, and 6 because just looking at this part of it. I mean, there's a lot going on here, but these parallel lines, these two, and this transversal. Okay? So let's see what I've got here. I've got that angle 3 corresponds to angle 1. That's 107. Angle 4 corresponds to angle 2. That's 73. And then this is 73. And this angle 5 is going to be 107. Okay? So those are just corresponding angles there. Now, what's left are these angles down here. So now I'm going to look at this parallel line and this parallel line, and this is going to be the transversal. So I play the same game. I look at corresponding parts. I look at the 9. That's going to correspond to the 48. I look at the 10, that corresponds to 132. And then I can just use vertical angles. There we go. Okay. Now, the only thing left there is the 17. And the way you can get the 17 is recognizing that for this triangle right here, you have 180 minus 73 minus 48. In other words, the sum of the angles is going to be 180. So I can just take 180 minus what I've already got. And that'd be 59. So that one's 59 degrees. Yeah. There we go. Okay. Now, we're almost through. I just want to look at one more here. I've got a couple of parallel lines cut by transversal. And I want to see what we're trying to do here is we're trying to figure out what X and Y are. Now, I know that what I've got here is 6Y plus 9X plus 12. I know that that equals 180, okay, because those are supplementary. And also I know that alternate interior angles are congruent. So I've got 9X plus 12 equals 13Y minus 10. Those are the properties I have. Now, those are not the only properties I could utilize. I could talk about 6Y plus is supplementary to 13Y minus 10. I think I'll do that actually. I didn't think about that, but I know that 6Y plus 13Y minus 10, that has to equal 180 because those are supplementary. So if I solve those, let's see what I got. I got 19Y, right? Minus 10 equals 180. And that will be 19Y equals 170. And then I can take 170, divide it by 19. Let's see here. Okay. Oh, look what I did. I was supposed to add. I had an algebra mistake. That's why this thing turned out looking bad. 19Y equals 190. There it goes. Now that gives me Y equals 10. Okay. There it goes. And an algebra mistake. Man, you got to be careful. Okay, so Y equals 10. Now, if I know Y equals 10, then what I've got here is 9X plus 12 plus 60. See, I just put a 10 in here, equals 180. See? And let's see what that's going to be. 9x plus 72 equals 180. And that means that 9x equals, if you subtract 72, you get 108. Okay? And then you take 108, divide it by 9, and you get 12. So x equals 12. There. Okay. Okay. Matt, my goodness, that's a lot. Thank you for your patience. Now, after all that, I just have these few problems for you to work, and we'll talk about these in class.